My name is Avirishu Verma. I'm a senior product manager in the Azure Compute team for the product called Virtual Machine Scale Sets, also known as VMSS.
Hi, I'm Shilpa Sharma, the Senior Product Manager for Autoscale that supports Azure resources with their scaling needs, VMSS being one of them.
And in this video, we're going to talk about the scaling capabilities offered with VMSS. Here's a quick intro to what we are going to cover today. We'll start with a brief introduction to VMSS, and then we'll talk about the different features related to scaling available to the users of VMSS. We also have a few demos that we'll walk you through today. Finally, we'll talk about a few tips for large scale deployments and share some additional resources that you can use. So let's get started. So, Virtual Machine Scale Sets or VMSS is an Azure service that allows you to deploy your compute capacity with dynamic scalability and high availability. With VMSS, you can create up to 1,000 VMs and easily manage them for your application. You can use either Windows or Linux VMs, and you can choose to deploy with spot VMs or regular on demand VMs. As part of VMSS, you can easily define a virtual machine profile, which can be used as a template for all your VMs in that scale set. For example, you can specify which VM size or SKU you would like to use. And if your application needs any extensions, you can add that also into the VM profile. For more details about the overall VMSS capabilities, you can refer to the VMSS webinar. The link is provided at the end of this presentation in the additional resources section. Now, here's a quick overview of all the benefits that VMSS provides to you. It provides a very simplified management so that you can focus only on your application development and not have to worry about taking care of your underlying infrastructure. VMSS also provides increased resiliency through availability zones and automatic OS updates for security patches. You also have a lot of options to take the benefit of cost optimizations. For example, use spot VMs or Azure hybrid benefit. And finally, scale and performance is one of the key value propositions that VMSS adds to your infrastructure. This is the part that we're going to focus on today. Again, for learning more about VMSS, you can refer to the VMSS webinar link at the end of the presentation. All right, so here's a quick reminder that with VMSS, you can deploy up to 600 VMs using custom images and up to 1,000 VMs using compute gallery images or platform images. Now, the simplest way to scale out or scale in your VMSS is by updating the capacity of your scale set. We'll look at the details of how to do this using Portal. Whenever you want to add more compute capacity, it could be because you need more resources to meet the increasing demand for your application, or it could be that you are looking for higher performance. You can simply add more virtual machines into your scale set by setting the SKU.capacity parameter to a higher number, and VMSS will automatically add new virtual machines to your scale set. Similarly, if you want to save on your infrastructure costs by removing some of the unused capacity, especially during the periods of low demand for your application, then you can simply set that VMSS capacity again to a smaller number, and the extra virtual machines will be removed by VMSS, and only the ones that you actually desire will remain. VMSS also offers some additional features for scale in so that you can have more control over how and when your virtual machines are removed from the scale set. We will walk through these features in the demo as well. These features are scale in policy, which allows you to configure what is the order in which the virtual machines should be deleted during a scale in operation. Instance protection, which allows you to protect one or more instances so that those are not deleted during any scale in operation. Terminate notification allows you to receive in-VM notification and also allows you to pause the deletion of a VM for up to 15 minutes so you can perform any cleanup operations if needed. And finally, you can also specify specific instances from your scale set that you would like to delete at the same time.
Standard Autoscale for VMSS provides dynamic provisioning of its resources, where it scales out to meet the workload demand as required and scales in when the resources are no longer needed. This helps our users save both time and money. Customers do not pay to use Autoscale, but they pay for the underlying resources. Users can create a standard Autoscale rule via Portal, CLI, or PowerShell, and further can view Autoscale actions via the activity logs provided in the portal. From conversations with Autoscale users, we discovered that the standard Autoscale method are great and can often help with efficiencies and cost. But there are certain workloads that may require longer lead times for provisioning and so seek to provision capacity ahead of the expected demand periods. In these cases, it is observed that the users resort to over-provisioning their resources, which leads to more spending. Predictive Autoscale can help in these scenarios. It uses machine learning to analyze traffic pattern and forecast future traffic. This forecast data is ingested and accordingly scaling takes place ahead of the traffic spike, helping users get the expected resources in time to meet their coming demand spikes.
All right, let's get into our first demo. First of all, what we're going to see is how to scale out or scale in your VMSs. As I mentioned before, this is simply done by updating the VMSs capacity. There is a parameter called skew.capacity in the VMSs model, which is what you can update and set to the desired number of VMs in your scale set. You can do this using Azure CLI and Azure PowerShell, and the links are provided here that you can take a look at for more details. We will use Portal for our demo today. You can also do the same by using REST API, and the links for the REST API docs are provided in the additional resources section. On the Portal homepage, I click on Create a Resource, search for Scale Set, click on Create, and start creating my new resource group as well as the new VMSs. I'll select the region that I want. I'll select flexible orchestration mode. And rest of the parameters I will leave as default, except for the password as my authentication method. Moving on with these parameters as standard as well. On the scaling tab, I specify 20 as the initial instance count. Then I go to review and create. And once the validation has passed, I'll click on create for creating this new VMSs. As you can see, the deployment is now in progress. Now that the deployment is complete, I go to the VMSs resource and I can see that 20 of the instances are being created now. I can check that in the instance list view. And these are all the instances that are being created and are now in the running state. Let's also check the template deployment for this VMSs. And in the VMSs model, we can see that the skew capacity parameter is set to 20. Now, let's say I want to increase the capacity of this VMSs and I want to scale out. I can simply go to the scaling tab and update the instance count from 20 to 25. Once I save this, on the overview page, we can see that the VMSs is now going from 20 to 25 instances. And let's quickly check the template once again. For VMSs, the skew capacity parameter has been increased to 25, which means that the VMSs is creating additional resources for me. And now I can see that those extra 5 VMs are being created as well. Similarly, if I want to scale in this VMSs, I can go back to the scaling tab and reduce the instance count from 25 to say 15. On clicking save, Back to the overview page, we see that the VMSS is now going from 25 to 15 instances. While the scale in is going on, we realize that we actually needed some more compute capacity because of a sudden increase in the demand. So back to the scaling tab, and we can increase the number of instances from 15 to 30. Now, even though the previous scale in operation was still in progress, VMS's capacity has been updated, and we can see that now it's going back up to 30 instances, and the required capacity for our application is being added now. Now, there is another VMSS which I created earlier with 20 instances, which I would like to use to show a few other features as well. The first one is called Scale In Policy. On the Scaling tab, there is another section called Scale In Policy, which has three different options: default, newest VM, and oldest VM. Which means that if I select the newest VM, the VM which has been created the last will be deleted first during a scale in operation. And if I select the oldest VM, then the VM which was created first will be deleted first. Let's select newest VM first. After saving, when I go to the instance count and update that from 20 to 18, let's see which VMs are going to be deleted by this VMSS. So here we can see that the number 18 and 19, which were created the last, are being deleted. Now, let's say we select the scale in policy as oldest VM first, and again reduce the capacity from 18 to 16, which means we are removing two more VMs. In this case, the ones that were created first are being deleted. This is a very useful feature that you can use to control the order in which the VMs will be deleted during a scale-in operation. The next feature is called instance protection. Let's say some of these VMs are particularly important for my application and I do not want to delete them. I can select those VMs and apply a protection policy for those VMs. In this case, I will protect the instance from scale in action. And once this is saved, I can see that the VM number 2 is protected from scale in actions. Now, if I delete further two more instances from VMSS, I will see that VM number 2 is still protected and not being deleted, even though that was created before 3 and 4. Still, VMSS is only deleting the number 3 and 4 VMs because the number 2 is protected. The third feature is called terminate notification. This is a feature where you can configure the number of minutes for which you would like to put the VM deletion on pause. This is really useful because you can use this feature to receive an in VM notification, and you can also use that notification to perform certain cleanup operations on the VM which is about to be deleted. The last feature allows you to delete specific VMs from the scale set. Let's say I want to delete the VM number 7 and 9 from the VMSS. I will simply select them and click on the delete button. You can also do this using REST API, Azure CLI, as well as PowerShell. So here are some more details about the features that we looked at in the demo just now. You can look at the links to learn more about them and also learn more about how to configure them. There is a link for the blog post also, which provides some more information about how the control and easier management during scale in can help your applications. Great. So let me now hand over to Shilpa to walk through some additional scaling capabilities. Shilpa, over to you.
With standard order scale, users can create users based off of min-max instance count, schedule, or metrics-based. Metrics-based rules can be created either using platform metrics or user-defined custom metrics. Let's take a look at the demo. In this demo, we will take a look at how to create and view standard order scale for VMSs via the Azure portal. I'm going to create a standard order scale rule for this resource by going to the scaling blade and then head over to the custom order scale section where I can create standard order scale rules based off of metrics or schedule, as well as enable or disable predictive order scale, which is our latest Azure order scale offering for VMSs and will be covered in a separate demo. As an example, I'm going to go ahead and create a metrics based scale out rule where every time my average CPU exceeds 50%, I'd like to scale out by one instance. In the rules page, I'm going to go ahead and assert that the metrics is set to percentage CPU, set up my metrics threshold to be 50%, and ensure that the action indeed indicates that it's going to scale out by one instance every time the average CPU exceeds by 50%. This I'm going to go ahead and add, and then I'll proceed to save. We now have a scale out rule enabled that will monitor my average CPU metrics and scale out as per the user defined rule. Let's take a look at the autoscale configuration already established on another VMSS resource. Here, the rules are created such that when the queue length is high, we scale out, and similarly, we scale in when the queue length is low. In order to view the autoscale actions, the user can head over to the Run History tab in the scaling blade and view the scaling actions accordingly. Over here in this chart, we see the observed instance count for the VMSs, and we see that at top of the hour, the users are adding work items to the queue, and as expected, the autoscale detects that and scales out accordingly. Now, when the queue drains, autoscale detects that as well and then proceeds to scaling in and reduces the instance count. And hence, we see the scaling out and scaling actions as expected in this particular chart. If the user wants to drill down further into the autoscale action, they can do so by viewing more details in the activity log that is available further in the link over here. Predictive Autoscale uses machine learning and scales VMSs that have cyclical workload pattern. By observing and learning historical usage, it predicts CPU usage patterns, ensuring the scaling occurs in time to meet the demand. Currently, Predictive Autoscale supports scale out only for average CPU metric. For any scale in action, user will need to create a standard autoscale setting. In addition to enabling predictive autoscale, users are provided with the option to enable forecast only, which allows them to view the predicted CPU traffic without triggering any scaling action. This helps users build confidence with the forecast model before enabling predictive autoscale itself. Let's take a look at the demo. Enabling forecast only or predictive autoscale is simple. In the scaling blade, the user can review the drop-down option available in the predictive autoscale section and make the selection accordingly. One of the prerequisites before enabling predictive autoscale is that user needs to create a standard autoscale rule, which we have seen in the previous demo. This is because it can not only handle any unexpected surge in the traffic, but it also provides as a fallback should ever the predictions fail. In continuation, when the user enables predictive autoscale, they have the option to enter the time that they would want the pre-launch of the instances ready in order to make it available before the workload demand. As an example, for this particular workload, I'm going to enable forecast only by selecting forecast only in the drop-down and clicking on save. It now confirms that forecast only is enabled on this VMSS resource, and hence it's going to start monitoring the historical workload pattern and start showing predictions when it's available. Let's take a look at a VMSS where predictive autoscale is already enabled. Initially, the user had enabled forecast only, and as next steps, headed over to the Predictive Charts tab, where they can view the predictions in comparison to the actual workload pattern. Predictive Autoscale needs a minimum of 7 days of history to provide predictions and about 15 days of data that gives us the most accurate results. Once available, the users can view them through the charts available here. The top chart shows the overlaid comparison of the predicted total CPU percentage over the actual, and this chart is spanned over the last 24 hours to the next 24 hours. The middle chart shows the maximum number of instances that were running in the past 24 hours, and the last chart shows the average CPU percentage shown over the last 24 hours. It is evident from the first chart that the predictions shown here in the orange line follows the actual workload traffic as seen in blue line very closely. From this, the user developed confidence and then went ahead and enabled predictive autoscale to manage their scaling in this particular environment.
Thanks a lot, Shilpa. Finally, we would like to highlight some useful points to keep in mind when you're designing your large scale deployments. Using the flexible orchestration mode for your VMSS and deploying with compute image gallery, as well as max spreading algorithm, will help you achieve high scalability and better performance. You can also leverage the Azure Resource Graph to query the properties of your VMSS at large scale and optimized performance. VMSS instance repairs is also a great feature to use that can help you maintain a healthy set of VMs in the scale set by automatically detecting and replacing any unhealthy VMs in the scale set. Finally, we recommend using standard load balancer instead of basic, especially for large scale workloads. You can learn more about these and other capabilities of VMSS through the resources mentioned here. Thank you very much for watching, and we hope you have a great experience using VMSS capabilities.
Thank you very much for watching. Should you require more details on autoscaling for VMSs, please refer to the additional resources. Thanks.